Alrighty, so now that you know how side works, let's actually do the practice sheet for it. Alright, so we have triangle WRT and 8 line segments are shown below. Alright, so I see that triangle and then we have these 8 line segments. Alright, so it says use patty paper, a ruler, or edge of a piece of paper. You know what? I'm going to use my trusty old compass here to help me with this. To determine which line segments have the same measure as each side of the triangle WRT. Alright, so let's do it first. Let's do WT first. Alright, so from W to T. Alright, I'm going to use my compass like I said here. Alright, it looks like it is about yay far. So what segment is yay far? Well, it's definitely not this one, this one, this one, this one. Alright, that looks a little better, but looks like it's a little short there. Alright, what about this one? Oh, definitely not. Wait a minute. That was too long, and this one should be perfect. Oh, look at that. GH. So WT has to be congruent to GH. Those are equal to each other. So let's write that. GH. Alright. What about RT? RT. Well, if we do that, it was a little harder to do. Alright. So I got that there. So what is RT congruent to? It's definitely not AB. Nope. It's too far. Too far there. What about CD? Oh, that looks like the sweet spot. So CD. So RT is congruent to CD. Alright, what about WR? What about WR? WR is about yay far. Seems pretty far. Let me get my finger out the way so you can see that. Alright. So what line segment? I know it has to be something down here. That'd be that one. Maybe. Oh, look at that. Perfect. I got that perfectly. MN. Alright. MN. Alright. That was pretty easy. Number 4 says construct a triangle using the line segments that have the same measure as the side of triangle WRT, and then we're gonna name it XYZ. So essentially, what's gonna happen is I'm gonna have a triangle, or I have triangle WRT, and that's gonna be congruent to triangle XYZ. All right. So WR. How long is WR? WR. I think I already put it back, but I guess I'll do that segment first. So WR is gonna be about yay long. Alright, so I'll come over here and I just do that. I'll just do a construction. Gonna be like that far. I guess I'll put my point there. So let's do that. I got WR somewhere there. That's my WR segment should be my XY segment. So XY. Alright. I'm going to do, I guess, RT next because that's my next segment. RT. So RT is yay far. So WR. So should be somewhere. I guess it could be somewhere here on that arc. But I'll just pick anywhere. I'll pick it there. All right, so that's RT will be, well, and I guess I'll do it in a different color so you kind of see what I'm doing. RT will become YZ, so Y, this needs to be Z labeled. And I guess I could just connect it because they must be the same, right? But I guess we'll connect WT, right? WT is yay long, so that should be about the same distance. Oh, wait a minute. I think I did this wrong. I'm gonna have to erase it. It has to be somewhere on this arc here. So it looks like they intersect there. So Z really sits here. All right, not there. All right, and I guess that was a little construction anatomy 101, but this is what my triangle should look like, and that would be Z. So now all my sides are equal, they are the same, and I could show you that if I erase this, so you can see that WR should be the same length as XY. So WR is the same length as XY. So those are the same length. There you go. Look at that. You can see that. All right. RT is the same as YZ. So RT is the same as YZ. You can see that there. And then WT should be the same as XZ. So WT should be the same as XZ. There we go. There we have it. You can see that there. All right. So we constructed our new triangle. So let's look at the back now. Let's look at the back now. All right. It says complete the statement. So the three sides of WRT are congruent to the three sides of triangle XYZ because WT, well, what was WT congruent to? So we see WT is congruent to XZ. We could see that, right? WT XZ. So we can mark that in XZ. What is RT equal to? Well, we know RT is equal to YZ, right? YZ. So we can circle that in. And then what is WR congruent to? Well, WR is congruent to WR is XY. Right? And that is why writing those down are super important. All right, let's answer number 6. It says determine if the angles of triangle WRT and the one we made XYZ are congruent. Explain how you know. Well, they are congruent. Well, because if every side is congruent to one another, so WR and XY are congruent, RT and YZ are congruent, and so is XZ and WT, then that means all of their angles are congruent as well. They're equal in measure because they're congruent via side. So we can say that here. The angles are all congruent because triangle WRT and triangle XYZ are congruent via side. That's all that says. Right? It's pretty neat thing to say, to do. All right, and last but not least, this looks fairly easy. It says a series of transformations were applied to segment CH, so CH, HN, segment HN, and NC. So it looks like this is my pre-image, right? It says complete the statements. The first transformation applied to segment CH, HN, and NC was blank. Well, it looks like my triangle stayed the same, and it looks like from here to here, it looks like my triangle stayed the same. It just shifted maybe to the left some, and then up or up left, however you want to say it. So that is I know for sure that's a translation. When you're just shifting up, down, left, right. So this results in CH equaling what? Well, if it was just shifted to the left, it means that would be MT. HN would become TR. NC would become RM. Oh wow, it's really that simple. Okay. Therefore, by the definition of congruence, of course we know that's our favorite word. Triangle HNC, which is here, is congruent to TMR. Yes, because it was just translated. That's a rigid motion. All right, number 9 says the second transformation applied to MR, RT, TM is a what? So how did this triangle get here? Well, the main thing that gives it away is this humongous 90-degree angle. All right, and the moment you see degrees, right? You know, you can assume it was rotated. So I know it is without a doubt it was rotated. Is a rotation. It was rotation. All right. So if it's rotated 90 degrees, well, what does my segments become? MR. What does MR become? Well, I know M, if it's rotated 90 degrees, it becomes, boom, has to make a right angle, becomes F. What does R become? R becomes P. So MR becomes FP. What does RT become? Well, R becomes P. Looks like T, 90 degrees, becomes W. And what does TM become? Well, T, 90 degree angle, so right angle, boom, becomes obviously W. And M becomes 90 degrees, F. All right. So therefore, about the definition, again, of congruence, triangle TRM is congruent to triangle what? Well, we got to make sure we keep our vertices in order. So T was congruent to W, so WR was congruent to P, so WPF. And I know that because M was congruent to F, or it laid onto F, right? And that's it. That's all the practice is for lesson 1.